starting with something like this. A lot of you were doing a lot of naughty things yesterday. So I want to re-go over what you can and can't simplify. And I went and asked another teacher, I'm like, I'm not sure what's not getting through to these kids. Like, I've tried, I'm like, I need a better way to explain it. And they kind of gave me an idea of how they would explain it. Hopefully it will help. So we have 2x minus 3. 2x minus 3 is connected because of the subtraction sign. Does everybody understand that? So it would not be okay to just say the 2 and the 2 simplify and divide them out. That would not be okay. Because 2x minus 3 is connected by a subtraction sign. Now if 2x times 3, we could divide out the 2's if it was just all multiplication. So with this one, you cannot simplify it any further. Is everybody good with that? Yes or no? Okay, so let's look at this next one. We have 2 times by x minus 3. Understand something. 2 is not connected. It's multiplication. With multiplication, it's technically not connected. Does everybody understand that? But that x minus 3 is connected because of the subtraction sign. Because 2 is just being multiplied to that, we can divide out the 2's in something like this. Once again, if it's multiplication, it's okay to simplify. If it's addition or subtraction, it's connected. Is everybody okay now with that? So 2 over 2 becomes 1 over 1, right? So this would just simplify to be x minus 3. So let's look at this one. 7x minus 7 over 49. Could I just simply, well, first of all, at this point, is 7x and negative 7 connected? Yes, by a subtraction sign. So we can't just take and just divide out one of them. But if we did factor the top, we could pull out a 7. So then left would be x minus 1. Now understand, x minus 1 is connected by a subtraction sign. So unless there's that exact thing on bottom, you cannot simplify it. But now 7 is being multiplied to all that stuff. So now you can divide the 7 out. It becomes 1, it becomes 7. So is everybody feeling a little bit more like, okay, yeah, now I'm seeing the difference. Okay. So let's look at these. This is where most of you yesterday were doing horrible, naughty, mathematical error-y things. You were seeing, okay, I have a w squared and a w, so I divide those out. You cannot do that. Now here's the reason. Isn't w squared connected to negative 25 connected by a subtraction sign to 25? So those two things are connected. Unless there's that exact factor on top, you cannot simplify it with what's on bottom. So this, you could not simplify any further. We could factor the top. The factor of the top would be w minus 5 times by w plus 5. And on bottom we have a w. Now, are there exact factors that can divide out? No, right? W minus 5, isn't it connected? Subtraction sign. W plus 5 is connected, subtraction sign. There's not that exact thing on bottom. So this didn't simplify any further. But looking at something like this, you could simplify it. W squared is only connected to w minus 5 by a multiplication sign. Thus, you can simplify it. Does everybody see the difference now between these two? The w is only being multiplied to all that. So now w squared over w becomes w over 1. Is everybody okay with that? Okay. I really think that's going to help us in tomorrow, starting tomorrow. Okay. So now, I really, truly don't feel like you guys have the foundation you need into where factoring comes from. After today, you'll have it. So here we go. We're doing number 1 on the worksheet I gave you today. Multiply 2x times x plus 8. This is going back a few, guys, this is going back a few steps. I promise I'm doing it for a reason. I wouldn't do it just to say, I'd like to teach an easy lesson. No, I'm trying to help you connect some dots here. So let's multiply this out. 2x times x, I know you know how to do this, that's 2x squared, right everybody? 2x times positive 8 is plus 16x. We all can do that, right? Yeah, obviously. Now I'm going to have us push pause so we can see something. Let's go backwards and factor this. Well, there's something in common in 2x squared and 16x. I'm going to factor it. They both have a 2x in common, right? So I pull out 2x. Is everybody okay with that? Don't they both have a 2x in common? So I pull out 2x. When you pull it out, you divide each term by what you pulled out. Right here, left, 2x squared divided by 2x is just x. And then 16x divided by 2x is plus 8. Now look at that. Aren't we back to where we were in the beginning? So factoring is literally the exact opposite of multiplication. Factoring is the exact opposite of multiplication. If you multiply two polynomials together, you get something like this. Now if we take this and break it apart into its factors, what we're doing is peeling back the layers and writing it as linear factors here. Now these, do you see how they're exact opposites of each other? They're literally equal, but they're just written differently. Sorry, I mean this and this are equal, they're just written differently. So factoring is just, we're pulling it apart. We're pulling the polynomial apart so we can see it in more basic pieces. So number 4, let's do this one. B squared times b minus 10. We would distribute, we know how to multiply. We would have negative b cubed plus 10 b squared. Now, I'm going to go backwards because obviously I know you know how to multiply. That's not the point of today. Today is seeing the connection here. So let's say we were here and we said factor. We would pull out what's in common in each term. So in each term, there's at least a b squared in common. But if we have a negative in front, we always pull out a negative with our factor. So I'm going to pull out negative b squared. Does everybody understand why? So then left-hand side, divide each thing by what you pulled out. We would have b, and we would have negative 10. Isn't that where we started? So does that make sense of where factoring comes from now? It's the exact opposite of multiplication. We're peeling back the layers. They're equal, different forms. Okay. So now let's do this one quickly. The multiplying part's not the important part. We would distribute. We would get 8b to the 5th. We would get negative 12b to the 4th. And then we would get positive 20b to the 3rd. Now we would look at this and say, what's the greatest thing in common? Well, all of them divide by 4, right? So I'm just having us go backwards because like we're building our knowledge. They all divide by 4, all the numbers, and they all at least have a b cubed. So I pull out 4b cubed. Now I'm writing what's left on the inside by dividing by what we pulled out. So then we have 2b squared minus 3b. And then we have 5b cubed divided by b cubed is 1. Is everybody making some connections here now? Okay. So I want you to do 1 through 15. In fact, you should all be able, and honestly, I think that you can do the whole front page because you should all be able to factor out the greatest common factor. That's going to be your biggest benefit because a lot of you would look at something like a lot of these problems and you'd say, I don't know how to factor that. So after today, you will. So ready, set, go. Do the front page. Guys, I'm going to just do a few problems. I cannot, if you don't want to watch this, that's fine, but just at least watch 1 or 2 of them. I'm going to do number 16 with you. It says, well, personally, I don't even like these instructions. I like the word factor. So looking at 15x plus 27, if you said this doesn't factor, just because it's quadratic doesn't mean it doesn't factor. If there's something in common, then it factors. So they both divide by 3. Let's pull it out. So I pull out a 3, what means I divided by 3 of each term to see what's left. 5x plus 9. Now check your inside. Could I have pulled out something more? No, 5 and 9, nothing more comes out. So I know I've done it correctly. A lot of times I'll factor out something and it won't be the greatest thing. And then when I get down to here, I look and say, oh, they both divided by some like a 2. So I should have pulled out another 2. So if you decided to pull out another 2, you just multiply it to what you already pulled out. And then you'd be good. I'm going to do number 19. So number 19, 72y to the 5th plus 18y squared. In common, the greatest thing is an 18 and a y squared. So then left hand side, divide each thing. 72 divided by 18 is 4. So we have a 4 left. And then y to the 5th divided by y squared is y cubed. When you divide, you subtract your exponents. And then don't say plus 0. My secondary 2 students would never say that. So you guys better not. That's 1. So that 1's very important. Is everybody good? Oh, I should have. Did I write that down right? Yeah, I did. Okay. But if you read the directions, it just says find the GCF. So you would have been good. I'm just showing you. Okay? All right. So everybody's good. Do I need to do another one? No? Yes? No? Okay. Do 16 through 48. Off today's worksheet. So I'm doing number 17. Here we go. So number 17. Let's clear on the back. Is everybody with me?
Oh, clear on the back?
Yep. So we're asked to factor this completely. Now I always check first to see if there's something I can pull out in the beginning, because these are going to be big numbers. And if I factor something out, it might be smaller. But unfortunately, 6 doesn't divide by 43, so we can't pull out anything. So we're just going to go ahead and do this. Now, once again, guys, this is what's good to recognize. Don't just automatically say, well, it multiplies to be A times C and adds up to be B. That only works for quadratics. But does this one happen to be quadratic? Yeah, degree 2. So then we're doing what multiplies to be A times C. Is everybody following me? So it multiplies to be 432 and adds up to be negative 43. Then you just take your calculator, start trying things. 432 divided by 2. 432 divided by 3. 432 divided by 4. So you're going to list them out. 16 times 27. Okay, that's how far I got. I kept testing them, couldn't find anything, and I got clear up to 16, and I'm like, oh, there we go. So, but it needs to add up to be negative 43, so they both have to be negative. Now, we cannot quick factor due to the fact that A is not 1. So we drop down our n terms, 6x squared, put these in. Doesn't matter the order, minus 16x, minus 27x. We're breaking down the middle term as those two terms, and we drop down the n term 72. Then we group the first two terms. We group the second two terms, including the sign. Then we look in each group and see what there is in common. In fact, the greatest thing in common. So in 16x squared and negative 16x, we're going to pull out positive 2x. Everybody's good here? So then left is 3x minus 8. Is everybody good? So far, so good. Okay, then we look in this group and say, what's the greatest thing in common? And we have a negative in front. So if it's a negative in front, we always factor out a negative. The greatest thing in common is a negative 9. So I pulled out a negative 9, and when we pulled it out, remember, technically we divided each term by negative 9. So then we have 3x, positive 72 divided by negative 9 is minus 8. Awesome, our safe haven's good, we've done it correctly. Because it's the same, we can pull it out. Now, a lot of you just have that magically evaporate into thin air. It doesn't just go away, it factors out. So then it divides out. A lot of you divide it out and it just disappeared. Doesn't. We factored it out. It's right there. And then left was 2x minus 9. Now, you would check to make sure you factored it completely, meaning in each linear factor, is there anything more I could pull out? And no. 3x minus 8, nothing more pulls out. And 2x minus 9, nothing more pulls out. Is everybody good with that? We're all okay? Okay. I'm not going to do, well, this is just what I wanted to show you. So a lot of times yesterday, this is what we got, and a lot of people didn't simplify it completely. Because look, if you factored something and got this, doesn't this piece factor more? Can't we pull out another 2? So we pull out 2 and left is x minus 1. And then we still have our 3x plus 5. So just make sure your linear factors are factored completely. Like in this one, it's not factored completely because 16x minus 32, we can pull out a 16. Left is x minus 2. And then we still have our x minus 1. So that was one point that I just wanted to make today, was to factor them completely. Is everybody okay with that? Do you see what I'm saying? This is really going to help us tomorrow and the next day. Okay, awesome. Now I want you to finish the worksheet. That's all I'm going to do today. Finish the worksheet.